How's it going, welders on YouTube? So we're gonna go over a groove weld test for aerospace. Now, if you want to follow along, I'll have this link below so you can look at D17.1 on your own, so you don't have to trust me and understand the weld test parameters yourself. But at least you'll get a lot of photos and extra explanations from me. So without further ado, let's do it. Okay, we're back, and what you see behind me is the groove weld test in aerospace. Specifically, this is aluminum 2-inch outside diameter, quarter of an inch thick. By far the hardest weld test I've ever taken. I failed this, I think, 7 times. I've never failed a weld test that many times. This one was a pain in the ass, and there was like a few guys where I worked that went years without passing it, and even the older guys had a hard time redoing their certs on just this one alone. So first off, you're just going to see what it is as I got it from the company. This is what's called a traveler. And as you can see, as we zoom in, it's got weld qualification, the type of weld. I guess the 2G is going to be the position, but as we go forward, you're going to see how that's questionable at best. And, just basic information about what I'm about to weld. And there goes one set of materials, and that's another set. As you can see, everything is controlled, labeled by the book. Now, D17.1, page 4, they're just going to go over some drawing requirements for the actual weld. So, essential information for all welds shall be completely described on the engineering drawing or in reference supporting documentation. When necessary, the engineering drawing shall show the profile cross-section of the complex weld joint with sufficient detail for the fabricator to determine essential features at any position along the length of the weld. And here's another important bit of information. Since this is considered a groove weld, it's going to be full penetration. So it's going to be a Class A weld, and it's going to be X-rayed. And we're going to be looking at figure 5.2. So even though this is a groove weld, when we're looking at it in the photo, in D17.1, it's kind of interesting. This is still considered a fillet weld in sheet, even though we just saw tube to tube just like this. And I'm highlighting this because this was the way that I welded it at the aerospace company I was at, the horizontal rolled position, which is pipe in a positioner, because you're performing the weld flat and you're rotating the pipe. And yeah, that's it for that. Now I have these side by side to make this a little bit easier to understand. So I'm welding 0.125 inches or quarter-inch aluminum, 2-inch outside diameter. So these up here on the right are the qualified thickness range. Now it says a test weld with the base metal thickness of T shall qualify welds with the thickness range of 0.67 T to 4 T. So basically what it's trying to tell you is that a certain thickness that you weld qualifies you to weld on a particular range of materials. Now I know we all suck at algebra, so I did it all over here. So the thickness of the aluminum is quarter of an inch, and that's the 67 T, because the T is a quarter of an inch, and then the maximum qualified thickness. So that's the minimum, and then that's the maximum right there, because it was a 4T, so 4 times T. So that quarter-inch piece of aluminum only qualifies me to work on 84 thousandths to half an inch. That's it. I can't work on anything thinner. And it goes into further depth right here. I can weld all that, but I can't weld thin aluminum with this particular certification. And that's just another picture found later on in the book. But zoom in, get your mind wrapped around it. I found it easier just to have it all like this. Moving on. Okay, so now that we understand what we're welding and what we're welding, what it qualifies us for. Sorry, tongue twister. So we started off with this, and this is just a traveler document for each individual aerospace company. So it might look different from one company to another, but that's just how the document travels from location to location, like machine shop to weld shop or to receiving, whatever. The other document that it's supposed to have is a WPS, a Weld Procedure Schedule. Now those aren't rocket science. It's crazy. You need to get paid $80,000 a year to know how to write these, essentially. But yeah, it's pretty easy. It's just fill in the bubble. So in the back of AWS D1.1, they have a sample weld procedure. Now, this is the weld procedure that I would use for this particular test. So, I mean, obviously, it's a little facetious, the Weyland Yutani Corporation, but yeah, we are welding aluminum. If you check on the other document, it's 6061 T4. And the filler metal that we're going to use is ER5356. The groove type, see, I consider it a double V groove, but AWS is calling it something different. The company is calling it something different. It's a groove. And here I put information that I would give to another welder, also keeping into consideration different people. So I consider this procedure to, yes, be 3 to 4 passes, a fusion pass, a penetration pass, and a cap pass. The process is obviously gas tungsten arc welding and preheat temperature. I wouldn't necessarily put a temperature, but when I say preheat it with a gas torch to reduce moisture, I mean, you could heat something up and it gets to probably, 100, 150 degrees. You're thinking like, like your stovetop at home. That would reduce most of the moisture on the aluminum. Filler metal size, I think you're going to need a range. 045, 1/16th, and 3/32. And of course, you're going to be purging this with argon. And now purging aluminum is also not necessary for all aerospace welds. It's really up to the OEM manufacturer that you're providing parts for if they require it. So I know Honeywell doesn't, but Lockheed does require a purge. Now for a test, yeah, we are going to be using a purge. So that'll be the flow rate of... Actually, well, this will be the flow rate of the nozzle. Oops. Yeah, okay, nozzle size. I have to put that. So yeah, that'll be the flow rate for the nozzle. The actual purge itself, I should have left over here. And I'd probably do that like 10 to 15 CFH for how small the item is. So you see, it's pretty easy to fill all of this out. You don't need to be a welding engineer. You just need to know the information how to pass the test. And right here, 70 to 150 amps. So I run mine at 100, but hey, every welder's different. Some might go a little slower, some might go a little hotter. I think this range could be extended even more. Electrode diameter, yeah, I would definitely at least do a 1/8. If you do a 1/16th or smaller, I mean, it should handle the heat for that period of time, but I'd rather have 1/8. But that's all for the welding procedure specification, so you can get an idea of how easy it is to write one of these. Yet, I don't know, you have to be a welding engineer to fill all this out. And in practice, when I've seen these, this range that I gave for 170 to 150 amps, for example, so that's what a welder thinks. I've seen engineers put 40 to 300 amps because they don't really know. They haven't welded this. They're just, looking at variables from another book. This is actual information from a guy who's failed the test multiple times and found out the hard way. Moving on. Okay, now we are back with the setup for this weld test. So, traveler document with the material. Now, to set this up properly and clean it, you're going to need this guy right here. It really helps out a lot. It's called a deburr knife. It's like a triple edge blade. And you're going to want to scrape off the surface of aluminum. The inside, as you can see, obviously the bevel, and then the top portion. I cleaned it off a little bit better than this. And then also too, you want to get that lip in there. Clean off as much of that oxidation as you possibly can. Then after you clean off the oxidation, you're obviously going to hit it with some acetone and yeah, wipe it down when you're finished. And then we had a V block like so, and you want to fit it up in there so you don't have any mismatch. And I mean, this was the one that passed, so this cleaning, even though it looks kind of rough, it worked. Then this was the type of purge that I used. I didn't make any of this equipment. This was already here. I made this. This was my personal purge. But yeah, anything, you know, to attach the aluminum, it's gonna have to be fairly sturdy on this end and, you know, pretty heat resistant because this is gonna get really, really hot. Okay, so this is a view of my setup just before we do our first pass. Now, I was taught how to do this by somebody, so I didn't make this up. So the first pass is what they considered a cold pass. But before we get into the pass, here's what it looks like. Nice and simple, lined up. You can see my amperage, 100 amps. And to weld this in a welding positioner, yeah, you don't want it to hold it from the material itself. So it's better if you have a saddle, one of these. You can put it in the chuck from the inside. You might be able to finagle it if you have a larger chuck, but what we had, yeah, we had to use this saddle. We had this in various sizes for different materials. And as you can see, I already did a pass there. Now that was my penetration pass. So that was actually pass number 2. So what you want to do for this weld is actually do a cold pass first. So you'll have the tack welds, and then you'll throw it in the saddle, and then just do one pass to fuse the two together. Now you do that cold pass, and you're adding just a little bit of rod, and you're doing that cold pass so the piece doesn't fall apart on you or move when you're actually doing the hot pass. And then let's go back. And there goes the hot pass. Now, as you can see, there's quite a bit of what looks like undercut. So other passes will follow. Now, the key to actually passing this weld test is being patient, waiting. You know, when I took this same weld test in Inconel, once you hit the pedal to rotate the positioner, you could basically just keep it going at a slow speed and the penetration will be even. With this piece, no, you don't want to do that at all. You want to start the puddle and you'll see the aluminum sink in, almost like, you know, you'll see it puddle up and then dramatically move down. That means you got penetration. Then you want to basically move the welding positioner a quarter of an inch, you know, maybe about half the length of your weld bead, and then stop. Wait till you see that drop again. Don't move. Just sit, wait until you see the drop, then add the rod, and then continue the process. Wait till you see the drop, add the rod. Wait till you see it, add the rod. There will be moments where you might be off the pedal for 2 or 3 seconds until you see it drop. Just trust it. Trust seeing that drop. If you just hit the pedal and continuously move the part, you will 100% get porosity. And that's how I failed it 7 times. I would get the puddle ready and I thought, okay, if I move it really, really, really slow, I won't get any porosity. No, you have to almost completely come to a standstill and just move once you see the weld puddle go down. And when you do that, the penetration on the inside will be beautiful. It'll be 100% uniform. I wish I had pictures of that. Unfortunately, I don't, but you get the outside. But that is the concept of passing this, which so many welders fail this test, but it's really just waiting. Once you see it drop, 1/4 inch on that positioner. See it drop, 1/4 inch. And I'm not even going full pedal on my 100 amps. I'm probably hanging around 70 to 90 at any given point. All right, so I hope you learned something about the groove weld test here. And if you ever have to take the test or know somebody that does, this is some good inside information on how to pass it the first time. I will include 2 other aluminum tests because at this company I had to get tested 3 different times. It was also tube to tube, but a much smaller diameter and thinner material, and tube to plate. And then I'll explain how all 3 of them, what range of thicknesses that covers. So next time. And yeah, you definitely got some really good inside information on how to pass a D17.1 test. A lot of YouTubers will actually show themselves welding, but how does that help you? I don't have the video of myself doing that, but I think the explanation of, how to control the machine, generally where the amperage is, a weld test procedure, from a welder who's passed it, I think that's good enough information for the average Joe to get 80% of the way there. Then your skills got to just take you the other 20%. So hope you liked it. Click a like if you learned something. I know you did, and peace.